Can you believe it? For the first time in half a century, we're doing it. Humanity is finally reaching beyond the cradle of Earth, turning our eyes back to that silent silver neighbor in the sky. April 1st, 2026. This is the day. After decades of dreaming, all that planning, all that building, the long countdown finally reached zero. And just like that, the silence was shattered. The engines of a brand new generation roared to life, starting to write the next huge chapter in our cosmic story. Because this time, it's a journey for all of us. This is the story of Artemis II. So let's get into it. On April 1st, 2026, Artemis II thundered into the sky from Kennedy Space Center. And I mean, this marked a truly historic return. This isn't just another trip up to low Earth orbit, you know? No, this is the big one. This is the first time in over 50 years. Think about that, 50 years that humans have actually ventured back out towards the moon. All right, so the Orion spacecraft has already completed its most crucial maneuver, the translunar injection. Basically, that's the massive engine burn that literally broke it free from Earth's gravity. It's now on its 10-day journey, and get this, the 4 astronauts on board, they're going to travel further than any Apollo crew ever did, looping all the way around the far side of the moon. You could say this mission is the ultimate stress test, right? For the technology for sure, but also for these pioneers who are paving the way for all the future lunar landings. But, you know, spacecraft is really just a machine, right? What makes this moment so historic, what gives it a soul, is the crew inside. So let's meet the 4 pioneers who are carrying all of our hopes on this absolutely incredible journey. Okay, so this crew, it represents such a profound shift from the Apollo era. I mean, it's night and day. It's led by Commander Reid Wiseman, but then you have Victor Glover, the very first person of color on a lunar mission. You have Christina Koch, the first woman, and Jeremy Hansen from the Canadian Space Agency, the first non-American to ever travel into deep space. And this is so important. This diversity isn't just about representation. No, it's a real strategic advantage. You're bringing a wider range of perspectives to solve these incredibly complex problems of deep space travel. And maybe most importantly, you're inspiring a new, truly global generation to look up at the stars. So when you see them up there, it makes you wonder, right? It raises the one big question that kind of hangs over this entire mission. If we pulled this off over 50 years ago, why on earth did it take us so long to go back? Well, the answer, as it turns out, it's pretty complicated. Probably the biggest piece of the puzzle comes down to 2 things: money and political will. You see, back during the space race, NASA's budget was a staggering 4% of all federal spending. 4%! But after we won the race and landed on the moon, that priority just vanished. Today, NASA's budget is about 0.4%. That's a tenth of its Apollo-era peak. I mean, with a budget that small, it completely changes what's possible, and, for sure, how quickly you can get it done. But it wasn't just about the budget cuts. It was about losing all that momentum. Think about it. After Apollo ended, the entire industrial ecosystem built to support it was just dismantled. The giant tools they used to build the Saturn V rockets, they were literally scrapped. The institutional knowledge just faded away as those brilliant engineers retired. So we couldn't just dust off the old blueprints and build another one. No way. We had to rebuild our deep space capability completely from scratch, designing brand new systems to meet safety standards that are way more rigorous than anything they had back in the 1960s. You know, that 50-year gap, it didn't just delay our return, it also created a vacuum where some pretty strange conspiracy theories about the original missions started to pop up. So before we look forward, I think it's worth it to just take a second and set the record straight. Look, the proof is just overwhelming, and it comes from multiple independent sources, not just NASA. You've got orbiters from India, China, and Japan that have all photographed the Apollo landing sites. We have 382 kilograms, that's over 800 pounds, of moon rocks that have been confirmed by labs all over the world to be from, well, the moon. And maybe the most convincing thing of all, scientists today, right now, still bounce lasers off special reflectors the astronauts left behind to precisely measure the moon's distance. The evidence isn't just here on Earth, it's literally still sitting up there on the moon. Okay, so with the past firmly confirmed, let's shift our focus to the future. Because Artemis II, it's not the final destination, not by a long shot. Think of it as the final dress rehearsal for a much bolder objective: getting humans back to the lunar surface, and this time for good. This mission is a super critical second step in a very methodical climb back to the moon. It follows the successful uncrewed test flight of Artemis I, which you might remember, and now it's setting the stage for Artemis III,
where astronauts will actually test their landing systems while still in Earth orbit. See? Each mission is a necessary rung on the ladder, all leading to the ultimate goal, Artemis IV, which is targeted for 2028. That's the one. That's when we are hoping to finally see boots back on the moon.
And this brings us to a final and I think really provocative thought. The Apollo program, that was all about getting there first. It was a race. But Artemis is about something totally different. It's about building a sustainable presence. We've proven we have the tech and the courage to get back to the moon. We know how to do that. But the real question, the one for this new generation, isn't how we get there anymore. It's whether we finally figured out how to stay.